Hi everybody! So in this video I'm going to be covering how we measure data in psychology. This is part of the Stage 1 Psychology Science Inquiry skills that you need to know in terms of how we measure data in experiments and investigations. Alright, let's go. So, measuring data in psychology. We use what we call descriptive statistics and we try and summarize the scores so they make sense. We can often get, thousands and thousands of numbers or responses. We obviously need to make sense of that. And there's several different ways we can do this. So we can present our results in a table, as you see here. We can obviously present them in a graph as well. So a graph such as this one. But before we do any of that, we have to obviously go through the process of what we call central tendency. So central tendency summarizes the center or midpoint of a distribution. And we use the four main measures of central tendency in psychology at year 11 level. So we always calculate the mean, the median, the mode, and the range. Now, we can have 10,000 numbers, for example. If we can then summarize them into four numbers that represents that data, that's going to give us a picture of the distribution itself and look at what was the average score, what was the middle score, were they influenced by outliers, what was the most commonly occurring number, and what was the range of responses. That's going to give us a snapshot and help organize the data into a more meaningful format. So let's go through each of the four measures of central tendency. So the mean. The mean is the most commonly used. This is also known as the arithmetic average. So the mean is actually the correct term in psychology. The average is the definition of the mean. So use the mean where possible. So it's very easy to calculate. So we add the values together and then divide it by the total number of values present. So if we look at our example over here, we've got 3, 4, 5, 7, 2, 3, and 5. So all we have to do is add up those numbers together. So 3 plus 4 plus 5 plus 7 plus 2 plus 3 plus 5, that gives us a total of 29. Now, as we can see, there are 7 values there. So 1, 2, 3, 4, 5, 6, 7. So what we then do is take our total, which is 29, and divide it by the total number of values present. So in this example, 29 divided by 7 gives us 4.1, and that's our mean score. So we always calculate the mean in psychology, but we can't just rely on the mean because it may be skewed or it may have outliers present. So we always then calculate the median. Now the median is the score found in the exact middle of a distribution. Now we always use the median as a more accurate representation when there are extreme outliers present in a distribution. So an outlier is an extreme number that's vastly different from the rest of the data set. So an outlier can be an extremely high number or an extremely low number. But if it's extreme in either direction, it's an outlier. And because this is psychology, outliers are more common, they're more expected because no two people are the same. It's more likely we're going to have outliers in a distribution. So to calculate the median, all we have to do is place the values in ascending order and find the middle number. So I've got some examples here. Let's talk through them. So here's my data set, 3, 4, 6, 7, 8, 10, and 125. So to find the middle number, I need to put them in ascending order, so from lowest to highest, which I've done here. Now, as we can see here, 7 is the median because there's 3 numbers below it and 3 numbers above it. So 7 is the median. It is the middle number. Now, that's all well and good if we have an odd set of values like we do here. But what happens when we have an even set of values and there's no one middle number? Well, let's go down to dot point 2. So we have 3, 4, 6, 7, 8, 10. So as we can see, we have 2 middle numbers. All right, so 6 and 7 are the 2 middle numbers because there's 2 numbers below 6 and there's 2 numbers above 7. So all we have to do there is we add up the 2 middle numbers. So 6 plus 7 gives us 13, and then we divide 13 by 2. So that gives us an answer of 6.5. So whenever we have 2 middle numbers, all we have to do is add them up and divide them by 2. And that gives us our median. In this case, it's 6.5. Now, as an example here, I've actually gone ahead and calculated the mean of this top data set here. Now, it's pretty obvious that there is a pretty significant outlier in our data set. So we've got 3, 4, 6, 7, 8, 10. Obviously 125 is an extreme number. It's a very, very high outlier compared to the rest. Typically it's not as drastic as that. Just for this video, I wanted it to be nice and straightforward for you. But 125 is a massive outlier. I calculated the mean of this data set, including that outlier, and the mean works out to 23.2. Now, as we can see, the mean has been skewed very, very high. 23.2 does not really fairly represent this data set because of that outlier skewing the mean way too high. So in this case, it's much better to use the median. The median is going to be far more representative of the data compared to the mean score down here. Now, it should also be said, guys, we always calculate the mean like I said before, but we typically always calculate the median as well. Now, if our mean and median are very, very different, like they are here, so a greater difference of 5, whether it's higher or lower, it doesn't matter, but if there is a big difference of 5 or more between our mean and median, there's outliers present, definitely. And there are here, so 7 and 23.2, that tells us straight away that our data is skewed and there are outliers present. Whereas if our mean and median are the same or similar, that means there's little to no outliers present in a set of data. Okay, now the mode. The mode is very straightforward. It is the most frequently occurring value in a set of scores. Now we only use the mode where necessary. We don't always use the mode. We only use it when the data is in category. So if we want to find the most commonly occurring response, for example, we would use the mode. What was the most frequently occurring number that kept coming up over and over again? So we calculate the mode by counting which value occurs the most. It's as simple as that. So here's my data set. I've got 2, 3, 4, 4, 5, 5, 5, 6, and 7. 5 is the mode because it occurs the most times. It occurs 3 times and it occurs more than any other value there. So 5 is the mode. Simple as that. Now, it's also worth noting that there can be more than one mode. Okay, we can have several modes. So if there were 3 4s and 3 5s, that would mean that 4 and 5 are the mode. All right, so we can have more than one. Sometimes we don't have a mode. All right, if there is no mode in a set of data, we never write 0 because 0 is obviously a value. So if there is no mode, we literally just write NA or no mode. Never write 0. And lucky last, it's often very useful to calculate the range of the data. So the range tells us the difference between the greatest and least values in a set of data. So all we have to do is take away the smallest value from the largest value. So it's a simple subtraction sum. So here's our data set, 3, 4, 5, 7, 2, 3, and 5. The largest number is 7 and the smallest value is 2. So 7 take 2 equals 5. 5 is our range. Now that kind of lends itself to the starting point of what we look at in Year 12 psychology, something called standard deviation, where we take it a step further and look at the average distance from the mean, or how much the score deviates on average from the mean score. The range is kind of the first step of that. So what's our range like in our data? Now we're not going to do standard deviation in Year 11 because we don't need to. We're going to save that for Year 12. But the range can be really useful to see what's the range of data from the highest value to the lowest value. That can give us a good picture there. Okay, ladies and gentlemen, that is how we measure data, numerical data, in psychology. I hope you found this video useful. As always, let me know if you have any questions. Happy revising. Bye.